Hello learners, I welcome you all to this video program on ocean deposits part 2. In the previous part of this program, that is part 1, we got a brief introduction to the ocean deposits and we discussed the types of ocean deposits on the basis of location. In this video program, we'll discuss the types of ocean deposits on the basis of its source and composition. We already started this portion in the previous video program already, and then we'll come to the horizontal and vertical distribution of ocean deposits and transportation of ocean deposits. So you now know that ocean deposits are the unconsolidated layer of sediments lying on the floor of oceans, and they are unconsolidated, so they are not a part of the crust and they are not lithified. However, they are important to study because since oceans are the final repository of all deposits from land, so many oceanographers might be interested in studying these deposits because they might have been deposited from the beginning of the history of the earth, and it's a long time. So in the previous video program, we studied about the types of ocean deposits on the basis of location. So on the basis of location, you can see there are three types of ocean deposits. Terrigenous, which is the shallow water deposit, then neritic, and pelagic, which is the deep water deposits. And we also started off with the types of ocean deposits on the basis of its source and composition. You can see that we studied the terrigenous deposits and different types of terrigenous deposits like gravels, sand, silt, clay, and mud. We also studied different types of mud like blue mud, red mud, green mud, and on the basis of different composition, why their color, different colors are emerging. And we'll now continue with volcanic deposits, deposits related to organic remains, inorganic deposits, red clay, and extraterrestrial matter. So let's start with volcanic deposits today. So you know, volcanic deposits are of two types. One is subaerial and the other one is submarine. Subaerial deposits are the product of volcanic eruptions from the land area, and they are mixed with several clay and alluvial deposits, and therefore it is hard to recognize them. So they are brought from the land area by agents of various agents of erosion like wind, river, etc., and deposited in the oceanic area. Submarine deposits, on the other hand, are those deposits which are directly deposited on the ocean floor, and they are formed due to upwelling of molten lava on the floor of oceans, generally along the mid-oceanic ridges or the tectonic zones having greater frequency of volcanism. Now, what are deposits related to organic remains? They are probably due to the decomposition of marine organisms which contribute a huge amount to these sediments, and they are of two categories, the neritic ones and the pelagic ones. We have already studied, you are already acquainted with these terms, like neritic are the shallow water deposits with low salinity, and they are composed of calcareous and siliceous deposits of various marine organisms, both plants and animals. And the pelagic deposits consist of different types of algae and shells of and skeletal remains of various sea organisms. They occur in the form of liquid mud, which is also known as ooze. When dried, it turns into an amorphous powdery mass. Now there are two broad categories of pelagic oozes based on their calcareous and siliceous nature. Now calcareous oozes are further divided into pteropod ooze and Globigerina ooze, and siliceous oozes are also of two types, that is radiolarian ooze and diatom ooze. Now let us study briefly about them. Pteropod ooze has 80% calcium carbonate and is formed of pteropod mollusks having thin conical cells with a diameter of about 0.5 inches. They are predominantly found up to a depth of about 800 to 1000 fathoms, and they are scattered along the eastern and western Pacific Ocean and are found in patches in Azores, Antilles, Canary Island, central ridge of Mediterranean Sea and Indian Ocean. Globigerina ooze is having about 64.47% of calcium and 64% silica and about 3.33% other minerals, and they are formed in shells of various foraminifera, especially Globigerina. They are widespread in both tropical and temperate waters and found extensively in Atlantic Ocean, in eastern and western continental shelves of Indian Ocean and eastern Pacific Ocean. They are also found at greater depths between 2000 to 4000 fathoms because they can tolerate both warm and cold waters. So they are found at a greater depths also. And in deep oceans, its color appears milky white, but along the coast it appears bluish gray in color. Now coming on to radiolarian ooze, they are siliceous in nature and formed of shells of foraminifera and appears dirty grey when dried. And they have since they are siliceous, so they have insignificant amount of calcareous content, which is only of the order of about 4%, and they are found in deep waters reaching up to 2000 to 5000 fathoms, and small patches are found in Indian Ocean, Atlantic Ocean, and is widespread in tropical regions of Pacific Ocean. Now, diatom oozes are formed due to decomposition of shells of various microscopic plants containing silica in abundance. They are also found at depths ranging from 6000 to about 2000 fathoms, and sometimes they extend even up to 4000 fathoms. They appear yellowish in general but turns white on drying and appears bluish when found near the coastal regions. They are found abundantly around the Antarctic Ocean and a narrow belt extending from Alaska to Japan in the North Pacific. When I'll show you the world map related to the horizontal distribution of ocean deposits, you will know in a better way how these are spread about in the entire oceanic area. Now, what are inorganic deposits? Inorganic deposits occurs in the form of inorganic precipitates, and they of dolomite, amorphous silica, magnesium oxide, and even phosphorus, clay, feldspar, etc. They are carried to the oceans by different, you must have studied the different agents of erosion when you have studied in the block on lithosphere. So these various agents of erosion bring these inorganic deposits from the continental areas and deposit in the oceanic area. So these are carried by these transporting agents like rivers, winds, etc. Now coming on to red clay, it is also regarded as a member of pelagic deposits. It is composed of hydrated silicates of aluminium. It is of the order of about 85.35% and also contains iron oxide. It is red in color, so it is differentiated from other pelagic deposits, which is imparted by the iron oxide especially. It contains more radioactive substance than any other marine deposit. It is soft, plastic and greasy in character and covers about 36.1% area of the ocean floor. It is found in the Atlantic Ocean between 40° north and south latitudes and the eastern part of the Indian Ocean and the northern Pacific Ocean. Now we are left with another important ocean deposit, another important type of ocean deposit, that is the extraterrestrial matter, which is also called cosmogenous deposits because they are in form of meteoric dust or cosmic spherules. And you must have studied in the block on atmosphere, like when these extraterrestrial matter enters the our atmosphere, due to friction of air molecules, they burn, and they are on also form they also occur in the form of burnt ashes. And these predominantly contain iron oxide particles, especially that of magnetite iron, and they are intact only in the deep oceans. Otherwise they are mixed with other sediments and are not easily distinguished. In the deep oceans, especially in the Pacific oceanic deeps, they are found. Now in this table you can see different types of ocean deposits in terms of percent of different types of ocean deposits of the total oceanic floor area. Like you can see that pelagic deposits occurs in about 75.5% area of the ocean, while terrigenous deposits only cover about 15.4%, and littoral and shallow water deposits are only 9.1%. So terrigenous deposits are the main ocean deposits, while others are only occupying the peripheral areas and are in say, very less percentage. Now let us study the horizontal and vertical distribution of ocean deposits. Since ocean is a three-dimensional body, like in the previous video programs, we had studied the horizontal and vertical distribution of other properties of the oceans like temperature, salinity, etc. So it is also worthwhile to study the distribution of ocean deposits in terms of horizontal and vertical distribution. In the horizontal distribution, you can see this world map that shows the distribution of ocean deposits in different areas of the oceans. You can see the red clay portion shown by the red color, and it occurs mostly in the Pacific Ocean. And let us start first with the terrigenous deposits. You can see the terrigenous deposits are occupying the areas closer to the coast or the shallow water area, and you can see it is shown in the white color. Calcareous oozes is also found in the major portion of the oceans, and it is shown in this map in the green color. And you can see some manganese nodules over here, and some hydrogenous sediments also. So what are these actually? Manganese nodules are actually rounded lumps of manganese and other metals that form on the sea floor, and they are about 3 to 10 centimeters thick, and sometimes may even reach about 30 centimeters. And they are due to one of the slowest geological processes, and they grow in the order of few millimeters over a million of years. And so they are rare, but they are important since deep sea mining is now going on, although it is very hard to explore the minerals and these kind of metals and nodules, but still oceanographers are nowadays exploring them. And they are formed in areas where there are low rates of lithogenous or biogenous sediment accumulation. So you can see in this world map that these manganese nodules are found in the mid of the major oceans, like Pacific Ocean you can see, then in the Indian Ocean in the mid portion you can see. Then there are ice rafted sediments along the polar areas. You can see along Antarctica and along the Arctic Ocean. You can see these kind of sediments, and So you can explore this map and see the distribution. In the question and answers session, you can see you can get some long questions related to the distribution of ocean deposits on the basis of its source and composition. Then you give all the different types of ocean deposits which I have explained, and you can just draw a rough sketch and show the distribution of these ocean deposits. And you can explore more better maps in the internet also. These hydrogenous sediments are also those sediments which are formed when seawater evaporates, and what is left behind is the minerals or solids, particularly halides like salt, NaCl. So these were the hydrogenous sediments which were shown in this figure, in this world map. Now in this table you see there are areas shown in million square kilometers which are covered by the pelagic sediments. So you can see most of these sediments are found in the Pacific Ocean, because it's a major ocean and comparatively larger in area than the other oceans like Atlantic and Indian Ocean, which we have studied. And so you can just explore this table and see the distribution of different oozes and ocean deposits in different oceans. Now, how do we study the vertical distribution of ocean deposits? It is studied in the form of various layers or strata, and it was first noticed by famous oceanographer Philippi in his famous Gauss expedition. You can see there are different layers or strata of ocean deposits, and we had earlier also studied that their coarser deposits are along the coastal areas, and as the carrying capacity of the waves or other agents of which bring the ocean deposits decreases, so coarser ones are deposited along the coastal area and finer ones are then found up to a greater depths of the oceans. And so there is a kind of gradation, like there's also kind of color change from in different layers or strata. Like you can see that these oceanographers who studied the vertical distribution studied that there's a kind of color change, like reddish brown in the upper portion and blue in the lower portion, and this may be attributed probably due to the reduction of iron oxide from ferric to ferrous state. And there is also a kind of gradation in the form of pelagic deposits, like pteropod ooze is found in the shallow water. Then, as I explained earlier, that Globigerina deposits are found up to greater depths compared to the pteropod oozes, because they can withstand both warm and cold water. So they are found at relatively deeper portions compared to the pteropod. And then radiolarian and diatoms are siliceous, so they are not easily dissolved, so they are found at greater depths in the oceans. And finally, red clay occupying the deepest portion. So kind of gradation like pteropod, Globigerina, then radiolarian, diatoms, and the red clay occupying the deepest portions. And as I explained earlier, that extraterrestrial deposits are also found along the ocean deeps, because they are not disturbed over there, so they are intact and they can be studied over there. Now let us study the transportation and deposition of ocean deposits. As I have been telling you in the previous video program also, and in this video program also, that these ocean deposits are brought by various agents of erosion like rivers, waves, currents, tides, and glaciers, winds, etc. And they are deposited in different areas of the ocean. So this is nothing new. You have already studied these things in lithosphere, in the block on lithosphere. And rivers are the main agents of erosion, so they not only break the continental rocks, but they also bring those boulders or gravels and deposit it in the ocean area. and you can see you have already studied that the coarser ones are deposited near the coastal area, and as the carrying capacity decreases, like waves, currents and tides, also they not only deposit the oceanic deposits, but they also transfer it to some great distances before depositing. So glaciers also are active agents of erosion in areas like high latitudinal and high altitude areas, and there they also are responsible for bringing these sediments and depositing in the oceans. And similarly, winds are also agents of erosion, and they are responsible for carrying the sediments to a great distance and then depositing. So you might see that inorganic deposits are not only found in the along the coastal areas, but they are deposited along the mid-oceanic areas also. And sometimes natural hazards or disasters like earthquakes, tsunami, floods, cyclones, etc., they bring enormous amount of debris and deposit in the oceans. So in this way, oceanic deposits are transported to different portions. So in this video program, we have studied the ocean deposits on the basis of its source and composition, which was a continuity of the previous video program, where we studied the ocean deposits on the basis of its location. And here we also studied the horizontal and vertical distribution of ocean deposits and how these deposits are transported to different areas in the oceans. And this brings us to the end of this block on hydrosphere. And in this block so far, we have studied in brief the hydrosphere, its different realms, and then we studied the ocean floor and the bottom reliefs of the oceans. So now you are acquainted with the terms like continental shelf, slope, continental rise, deep sea plain, oceanic dips, guyots, submarine canyons, etc. And you have then studied the distribution of temperature and salinity in the oceans, and in different video programs we have studied these elaborately. And then we have also studied the oceanic circulations in the forms of waves, tides and currents. So you learned different types of tides, and what are the factors and theories related to the origin of tides and ocean currents. And now finally you studied about ocean deposits. So this brings us to the end of this block on hydrosphere. In the next video program, we'll just study the learning outcomes of different units of this block on hydrosphere. So thank you and keep watching.